Hey everyone, so this was from your chapter 4 test, actually, the part 1. I wanted to show you guys how to do number 3 because a lot of people have trouble with this one. It's a very particular process. You cannot solve inequalities directly if they're not linear. So if it's a quadratic inequality, you guys had one of those on the other part of your test, on the online part. Or like on this one, it's a rational inequality. You have to use this test value method, and this is going to be on the final exam. It's really important. And if you're moving on to pre-calc and calculus, this is going to be really important. So here's what you do. First of all, you want 0 on one side of the inequality, and you want the other side to be simplified. So I'm going to subtract the 3 over. So I've got 0 on the right side, and then I'm going to get a common denominator and actually simplify this. So if I multiply the 3 times x plus 5 over x plus 5, now be careful when you distribute the 3, you're actually distributing a negative 3, so just be careful of that. So you get x minus 2 minus 3x minus 15. Okay, which simplifies to be negative 2x minus 17 over x plus 5 is less than 0. So then what we do is we find what are called critical values. So we're looking for what values is something critical happening. Where is something significant happening? And so 2 things we would want to look at. The first thing would be any asymptotes. So what if the denominator is 0? Well, there's an asymptote at negative 5. That's probably pretty critical. That's important. The other one that we care about is the x-intercept. So what if I set the numerator equal to 0? So then I get x equals negative 17 halves, which is like negative 8.5. Okay? So now, I'm going to erase this. If you need to pause and take notes, you can. We're going to set up a number line and try to figure out what's happening in each of our intervals. So negative 17 fifths, or negative 17 halves, is less than negative 5. Okay? And so what this does is it separates my number line into 3 intervals. So, and it's not always 3, just in this example it's 3. So I have the interval that's less than negative 17 halves, the interval that's between negative 17 halves and negative 5, and the interval that's greater than negative 5. On this problem, everything was not included. It was just less than, not less than or equal. So we're going to use parentheses for the entire problem. But now what I'm going to do is I'm going to pick test values. In each interval, and just try to figure out what's going on. What I'm looking for in this problem is is this inequality true? So in other words, if I plug in, say, 1 or whatever, is my inequality going to be less than 0? Is that going to actually work? Okay? So the question is, is my inequality actually true? So in this case, less than 0, negative numbers are good numbers, okay? So something less than negative 8.5, let's say like negative 10. So if I plug in negative 10, I'll get 3 over negative 5, which is negative, okay? So that means that this interval less than negative 17 halves is part of my solution. I like that interval. Now let's pick something between negative 17 halves and negative 5. Say like, we could do negative 6. So that's negative 5 over negative 1, which is going to be a positive number. So that interval does not work. So negative 6 was in between. We don't like that interval. So now let's try something bigger than negative 5. We could do 0. 0 would be easy. So negative 17 over 5, yep, that's negative. So guess what? We like that interval. Greater than negative 5. So then my solution, I think I can just fit it right here. My solution would be from negative infinity to negative 17 halves, union negative 5 to infinity. So just make sure you know how to do that one. You'll want to study that for the final exam for sure, or at least something similar.